Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to solve systems of equations algebraically using the elimination method. How are we learning it? Through the systems of equations using Elimination Part III notes and the systems of equations using Elimination Part III assignment. When can we use this information? To find economic solutions to financial problems such as income versus expenses and supply versus demand. How do you know you learned it? By getting a score of 4 on the systems of equations using Elimination Part III assignment. Now let's take a look at our agenda for today. We'll begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed the Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the solving systems of linear equations using Elimination Part III notes. And then I'll give you time to complete the solving systems of linear equations using Elimination Part III assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the systems of linear equations and inequality study guide and any incomplete assignments that you may have. Let's take a look now at the solving systems of equations using Elimination Part III notes. Our notes begin with the learning goals and success criteria. Now let's take a look at how we can graph systems of linear equations. So all this really means is we're going to graph both of these lines at the same time. So on the first one, we'll go ahead and graph this. So we're going to plot our y-intercept, which is -2. So we're going to go down 2 and plot our point. And the slope is 1/3. So we're going to go up 1 to the right 3. Plot our point and connect the dots. So just like we did earlier, that's the same thing we're going to do now. Now we're just going to plot the second line on the same graph. So my y-intercept for this one is 3. So I'm going to go up 3 and plot my point. And my slope is -1/2. So I'm going to go down 1 to the right 2. Connect the dots. And notice now I have a point where they intersect, which is right there. That is considered the solution to the system of equations. Now let's talk about how we can solve this without having to graph. So if we're given something like this, 3x minus 2y is equal to 24 and 3x plus 2y is equal to 12, we're going to go ahead and solve this using what we call elimination. So here are the steps. First step is we're going to check for opposite x values or y values. Now opposites mean they have the same integer but with opposite signs. So for instance, we have a +3 and a +3. Those are not opposites. We have a -2 and a +2. Those are opposites. So these two represent opposites. So if we have opposite x or y values, we're going to go ahead and add the equations together. So we're going to add the entire equation. So we'll add these up. So we add 3x plus 3x and we get 6x. -2y and 2y is equal to 0, right? So that's the elimination part. We eliminated the y's. And then 12 plus 24 is 36. So we end up with 3x is equal to 36. Now we're going to solve for x. So 6 is being multiplied by x, so I undo it by dividing. So we divide both sides by 6, and we get x is equal to 36 divided by 6 is 6. So that's x. Now we know the x coordinate of where they cross, but now we need to get the y coordinate. So we're going to plug 6 in for x into one of the two equations. It doesn't matter which equation you pick, as long as you plug in x as being 6. So we'll go ahead and pick this one. We'll pick the first one. And we're going to plug 6 in where x is. So instead of being 3x minus 2y is equal to 24, it's going to be 3 times 6 minus 2y is equal to 24. So 3 times 6 is 18. So we get 18 minus 2y is equal to 24. We need to get rid of this 18. So we're going to subtract 18 to get rid of that. And we're left with -2y is equal to 24 minus 18 is 6. We'll divide both sides by -2, and we get y is equal to -3. Now let's take a look at another example. So we're going to check for opposite x values or y values. So we have a +1 and a -2. Well, they have opposite signs but not opposite values. We have a -1 and a -1. So again, we don't have opposite values. So if we don't have opposite values, we're in trouble. So what we need to do is we need to create opposite values. we need to multiply either one or both of the equations by some number to get opposite values. So in this case, the easiest looks like it might be the y's, because we could just multiply one of these by a -1, and that gives us a positive y and a negative y. But we could also do the x's. We could multiply this whole thing by 2. That gives us a positive 2x and a negative 2x. But we're going to go ahead and do the top one by -1. If we multiply the top one by -1, we get positive y and negative y. Now, here's the deal. Anytime we multiply this, we have to multiply everything. So that's the x's, the y's, and the constants. Everything's got to get multiplied. So when we do that, we get -1 times x is negative x. -1 times negative y is positive y. And -1 times 11 is negative 11. So what we're left with now is negative x plus y is equal to negative 11. And the bottom one didn't change. So now, notice we have opposite x and y values. So now we just follow the steps we did previously. So then we're going to add the equations together. And we get negative x and negative 2x is negative 3x. These cancel out. And we get negative 11 plus negative 19 is negative 30. So we have negative 3x is equal to negative 30. Now we just solve. So we divide both sides by negative 3. And we get x is equal to negative 30 divided by negative 3 is positive 10. So there's our x value. Now we're going to plug that in to one of the equations and solve for the y value. So I'm going to go ahead and use my new equation. I can use the new equation or any of the two that I started with. I'm going to just use the new equation. That's fine. So I'm going to plug 10 in for x. So this is negative 10 plus y is equal to negative 11. I add 10 to both sides to get y by itself. And I get y is equal to negative 11 plus 10 is negative 1. So y is negative 1 and x is 10. Let's look at another example. We have 5x plus y is equal to 9 and 10x minus 7y is equal to negative 18. So again, check for opposites. Well, 5 and 10 are not opposites and 1 and negative 7 are not opposites. So I need to create opposites. So I could multiply this one here by negative 2. That would give me negative 10x and 10x. Or I could multiply it by 7, and that would give me 7y and negative 7y. I usually want to multiply by the smaller number because it keeps everything a little easier to manage. But it doesn't matter either way. This time I'm going to multiply by negative 2. So I get negative 2 times 5x is negative 10x. Negative 2 times y is negative 2y. And negative 2 times 9 is negative 18. So now I have negative 10x minus 2y is equal to negative 18. And the bottom one just drops down. So I have 10x minus 7y is equal to negative 18. And now I have opposite x values. So I can go ahead and add the equations. These will cancel out. I'm left with negative 2y plus negative 7y is negative 9y. And negative 18 plus negative 18 is negative 36. So now I just need to solve for the variable. So I'm going to divide both sides by negative 9. And I get y is equal to negative 36 divided by negative 9 is positive 4. So that's my y value. Now I need to plug it into one of the equations to solve for the x value. So I'll use 5x plus y is equal to 9. And I'm going to plug 4 in for y. So now this says 5x plus 4 is equal to 9. Well, now I need to solve for x. So I'm going to subtract 4 from both sides. And I get 5x is equal to 9 minus 4 is 5. Divide both sides by 5. And I get x is equal to 1. Now let's take a look at another example. This time, though, we're going to notice something's a little different than the last one. So it says 5x plus 4y is equal to negative 30, and 3x minus 9y is equal to negative 18. So we begin, like always, by checking for opposite x values or y values. So 5 and 3 are not opposites, and 4 and 9 are not opposites. So we're going to have to create opposite x or y values by multiplying. Now on all the previous ones, one of the coefficients was a factor of one of the other coefficients. So we were able to just multiply one of the equations. Now what we should notice though is I can't multiply 3 by anything to get 5. And I can't multiply 4 by anything to get 9. So I'm actually going to have to multiply both of the equations now. So I can pick either the x values or y values. Now the y values are going to get really large if I start multiplying by 9. So I'm going to use my x values, and I'm going to multiply the top one by -3. That'll give me -15. And the bottom one by 5, which gives me +15. So now we have a -15x and a +15x. And then we're going to multiply that times everything here. So -3 times 5x, and -3 times 4y, and -3 times -30. And then I'm going to do the same thing on the bottom. So 5 times 3x, and 5 times -9y, and 5 times -18. And when I do that, I end up with -15x minus 12y is equal to 90, and 15x minus 45y is equal to -90. Now notice I have opposites, so now I can go ahead and add the equations. My x's will drop out. I end up with -12y plus -45y is -57y. And then I have 90 and -90, which is 0. So I'm left with -57y is equal to 0. I divide both sides by -57 to solve for the variable, and I get y is equal to 0. Now I'm just going to plug that back into one of the equations and solve for x. So it doesn't matter, I can use any of the 4 equations now that I created. So I'm just going to use this one. So I have 3x minus 9y is equal to -18, but y is equal to 0. So I plug that in. Now I have 3x minus 9 times 0, which is just 0, is equal to -18. So this just drops out. I'm left with 3x is equal to -18. Divide both sides by 3, and I get x is equal to -18 divided by 3 is -6. Let's look at another example. We have 3x minus 2y is equal to 2, and 5x minus 5y is equal to 10. So again, I'm going to check for opposite x or y values. 3 and 5 are not opposites, and -2 and -5 are not opposites. So I need to create opposite values. Again, I can pick the x's or the y's, it doesn't matter. I'm going to go ahead and choose my x values. So I'm going to multiply this one by -5, and this one here by 3. So that gives me -15x and +15x. Now I can just go ahead and multiply. When I multiply this out, I end up with -15x plus 10y is equal to -10. And when I multiply this one out, I end up with 15x minus 15y is equal to 30. Now I have opposites, so I can just go ahead and add them. The x's cancel out, and I'm left with 10y plus -15y, which is -5y. And -10 plus 30 is 20. So I'm left with -5y is equal to 20. I'm going to solve, divide both sides by -5, and I get y is equal to 20 divided by -5 is -4. Then I'm going to plug that into one of the equations and solve for x. So I'll pick 3x minus 2y is equal to 2. I'm going to plug -4 in for y. Then we'll combine these, so we have -2 times -4 is +8. So we get 3x plus 8 is equal to 2. Subtract 8 from both sides. And we're left with 3x is equal to 2 minus 8 is -6. Divide both sides by 3, and we get x is equal to -6 divided by 3 is -2. Now there's a video here that shows you how to check systems of linear equations in Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check our work when dealing with systems of linear equations. So first thing we're going to do is go to desmos.com, which is here, and we're going to click on Graphing Calculator. Now, this allows us to type in our equations over here. So let's go ahead and put in an equation. So let's say it's y equals 2x minus 4. So there's our first equation. Now we're going to type in our second equation. So we're going to go to the line below it, and let's say it's y equals -2x plus 4. So there's my 2 lines, and if I go to where the 2 lines intersect and click on it, I can see that it gives me the coordinates of exactly where the 2 lines intersect. They intersect at x equals 2 and y equals 0. So this would be the solution to my system of equations. And I can do this by inputting any 2 equations and then going to the point of intersection and clicking on it. It will tell me what the coordinate of that is, with the x coordinate first and the y coordinate second. So this is how you can check your work using Desmos when dealing with systems of linear equations. Let's take a look now at the solving systems of linear equations using Elimination Part III assignment. The assignment begins with our learning goals and success criteria. If we scroll down, we can see the questions. It says to solve the system of linear equations using elimination. So if we notice, in this case, our x's are already opposites, so we can just go ahead and add these up, and our x's will cancel. So we have negative 2y plus 8y is 6y, and negative 12 plus negative 24 is negative 36. So 6y is equal to negative 36, so we divide both sides by 6, and we get y is equal to negative 36 divided by 6 is negative 6. Well, the only one with negative 6 for y is this one, so that would be our answer. So we'll answer each of these questions just like that, and then we'll go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go, and then submit your work on Google Classroom.